Hello YouTube, it's Akash with another video on physics. We will be discussing laws of motion today and solving the questions of AC VERMA. So it is the 28th question of laws of motion. Let m1 equal to 1 kg, m2 equal to 2 kg, m3 equal to 3 kg. Find the accelerations. A string from the upper pulley to the m1 has a length 20 centimeter. We have to find the time taken by m1 to strike the pulley. See, this is the diagram given in the book. So we'll draw it. See, I have named them P1 and P2. So we'll try to understand the mechanism in P2. Sorry. Let us assume this is the pulley P2, okay? Or rather, I write it here. So we will now try to find it very easily. That let us assume one end of the rope is fixed. Rope or string passing over P2 is fixed. So it can only descend along the mass m, along the mass m3. Okay, right. So you see the brown color shows the initial position of the mass m3. But as P2 descend to an amount x, what happens? As P2 descend an amount x, the rope gets slung by an amount of x plus x in both directions actually. So it actually slings by an amount 2x. So the mass m3 descend to an amount of x plus x is equal to 2x. If it is clear to you, you can see this rope, as this rope cannot descend this way, it will only descend in one direction. And thus a pulley descending by an amount of x will result in the descent of the mass hanging to an amount 2x. Similarly, if pulley descend with velocity v, it will result in the mass to have a velocity of twice v. If it descend with an acceleration a, the mass will descend with an acceleration of twice a. If it is clear to us, now we can move to solve the question. So what the question says? Question says a mass m1 of m2 and m3 are hanging in these orientations. So let us assume m1 is rising with an acceleration a1. Okay. So as a1 is the acceleration of m1, so P2, as it lies on the same string, the P2 will descend by an amount of a1. And let us assume m2 is rising. Earlier we saw that this end of the rope is fixed. In case of the previous case, this end of the string was fixed. But here it is rising. This end is rising with an acceleration a2. So this a2 will result in m3 to have an acceleration downward. Let us assume it is of a3. So a3 is equal to, see, because of a2 it will have an acceleration downward of a2. Again, as pulley is descending by an amount a1, the mass will m3 will now descend with an amount of twice a1. Is it clear to you? A2 is because of this a2 and twice a2 is because of the pulley going downward with an acceleration of a1. So this is the first equation we have found out, right? Now let us move on to get further equation. First of all, we will see that since tension in this rope, let us assume it is T. So since it is the same rope, it will also have a tension of T. But as the pulley is having a tension of twice T downward and to be in constant in a constant position, it should have a tension of twice T upward as well. To have a constant motion, it will have a constant velocity. It will have a twice T upward also. Similarly, we can see this rope, being the single rope, will also have a tension of twice T, right? So now we will draw the free body diagrams of all these masses. So m1 has a twice T upward, an acceleration a1 upward, and an m1g downward acting. Okay. See, m1 has a mass of is equal to 1 kg. First of all, we'll note it down. m2 has a mass of 2 kg, and m3 has a mass of 3 kg. This will be easier for us to solve. M3 has an m2 and m3 both has an tension T upward, m2g downward for m2 and m3g downward for m3. So these are the basic things, and we have drawn them out very easily. Sorry, a3 has an acceleration a3 downward, as we have assumed. Now we will write the equations for all these bodies and actually gradually replace them with their values of the mass. So first of all, for m1 the equation is twice T minus m1g is equal to m1 a1, right? For m2 it is 2t minus m2g is equal to m2 a2. For m3 it is m3g minus t is equal to m3 a3. Since we know the mass of this substance, we can write them in this form, that twice t minus g is equal to a1, t minus 2g is equal to 2a2, is 3g minus t is equal to 3a3. So these are the four equations we have reached, and we'll now try to see there are only four variables, 3 acceleration, 1 tension. So and there are 4 equations. So we can solve these out very easily. So let us solve them out and get their values. This calculation will not be shown. So after solving these 4 equations, it's equal to twice a1 plus a2 1. So after solving this 4 equation, we'll reach to the solutions this. So we can see the tension, we can see the accelerations. Now we have to find the time taken for the mass m1 to reach the point of attachment of p1, and this distance is actually is equal to 20 centimeters given in the question. So is equal to 0.2 meter, right? So we have to find we know that distance is equal to ut plus half at square. Since the initial velocity was 0, so u is equal to 0, but distance is equal to 0.2 meter is equal to u is 0 into time t plus half a, and we know the value of a is a1 dot t square. So we'll now put the values of a1 to get it. So t is equal to 0.2 into 2 divided by a1, right? Divided by a1 root. So now we'll put the values of a1, which is nothing but 0.2 into 2 by a1 has a value of 19 by 29 g, right? Is equal is root over it 0.2 into 2 into 29 divided by 19 into 10, and this value is almost close to it's almost is equal to 0.25 second. So we have reached the time taken. Again we have got the accelerations also, and again also we have got the tension. So we have solved the question. Hope you like, share this video, and subscribe my channel NEET, the AKASH videos, and press the bell icon to get notifications instantly. Keep watching.